In InfoDrainage, the 1D, 2D analysis uses a 1D simulation engine to calculate the flows in the pipes, manholes, and other structures below the ground, in combination with a 2D simulation engine to predict flood flows across the catchment surface. This enables the program to represent the overflow from the sewer or channel network, the movement of the flooded water on the surface, and the re-entrance of the flooded water back into the sewer or channel network. The 1D simulation engine and the 2D simulation engine run simultaneously during the 1D, 2D analysis in order to enable dynamic coupling between the two engines. Each simulation engine runs with its own computational time step, and the two engines sync up at regular intervals. There are three areas in which the exchange between the two engines can happen in InfoDrainage: at manholes, along the banks of open channels, and along the outline of stormwater controls. The overflow can happen in one location, while the re-entrance of the flooded water can happen in a different location, depending on whether the flooded water will move on the surface after coming out of the 1D network. There are no limits on how many locations the water can be exchanged or how many times the water is exchanged. So, for example, InfoDrainage can be used to represent flooding coming out of an open channel. Then the floodwaters flow on the surface to some lower ground where the water is captured by a pond. Eventually, this pond fills up and floods itself. The floodwater flows further away, following the terrain slope and features, and it ends up near a manhole where it is captured and goes into a conduit. Note that in this example, the open channel, the pond, and the manhole do not need to be connected by the same 1D network. They can be connected to different outfalls. The computation of the exchange between the 1D network and the 2D surface accounts for the respective heads at the location of the possible exchange. The flow exchanged is calculated using an orifice equation for the manholes and a Weir equation for the channel banks and pond outline. For the latter, due to their linear nature, the Weir is split into multiple segments, accounting for vertices in the 2D mesh, and hydraulic calculations are done on each individual segment. The 1D, 2D analysis is typically more computationally intensive than the regular 1D only analysis, due to the extra effort of running the 2D engine and the overhead of the exchange between the two engines. The increase in analysis time depends on factors like the amount of water in the 2D domain, the percentage of the 2D domain that is wet, and how many locations the water is exchanged between the two engines. Lastly, it is important to understand that the 1D, 2D analysis runs for one phase and one event at a time.